All right, right away as we start correcting this one, I've got some bonus information here about the distributive property. Remember, a distributive property tells us you can multiply the outside number by both inside numbers, or I guess all of the inside numbers. So like, for example, if I had 3 times x plus j, that would mean I could do, this is the same thing as 3 times x plus 3 times j. You can go forwards and backwards with it. What I mean by that is you can also factor out an identical number from two terms. So let's look at this problem. It says Jim and Jeannie were both given the following expression, 48 plus 12 in parentheses. Jim produced the following expression, and he said that's equivalent. And remember, equivalent makes us think they're the same, they're equal. And Jeannie produced the following expression and also said it was equivalent. So she looked at this and she said, hey, that's also equal. So they're both saying these two things are equal to that one. And we want to say who do we think is correct in this situation and explain that using the given space. So when you get to Park, you're going to have scratch paper to work stuff out, but then you're going to be expected to enter your answer in a space that looks like this. You'll have tools off to the right like this, and it'll tell you to write it right in here. You'll have a redo button, an undo button, a delete everything button, all that kind of stuff. So let's actually think about this. Let's actually start to plan this before we actually write with our writer's CFS. Well, let's see. We could look at it two ways, right? If I have 48 and 12, let's start that way. Let's start with the division. No, let's start with Jeannie and Jim. So if this is what we have, right? Well, according to the distributive property, I can do this. I can say 12 times 4 plus 12 times 1. Or I can do 6 times 8 plus 6 times 2. Okay, well, if that's true, let's actually think about it. Let's see. 12 times 4, that's 48. 12 times 1, that's 12. Well, it looks like Jim is at least correct using multiplication because the distributive property says I can multiply outside number by both inside numbers. Now look at Jeannie's, I get 48, that's 6 times 8, plus 6 times 2 is 12. Well, it looks like Jeannie is also correct. Jeannie is spelled like that. I'm not sure how to spell even the names I make up. So it looks like they're both correct using multiplication if we use the distributive property that way. Let's think about it the other way, though. If we take 48 plus 12, 48 plus 12, they both have a lot of common factors. So for example, I can think of it like this. I can factor a 12 out of both of these numbers, right? I can think 12 times 1, and I can think 12 times 4. And using my distributive property, I know I can take the common factor and factor it out of my expression. So that would leave me with 4 plus 1 on the inside. So it looks like, according to Jim's work, Jim is still correct if I do it this way. And then with Jeannie, it's kind of the same idea, right? I can factor a 6 out of both of these. I know 6 times 8, 6 times 2. Here, the common factor is 6. So that gets factored out, and I'm left with 8 plus 2 on the inside, not any different than what we see above. So here, I have to think, well, both are correct. Both are correct based on what I've shown. But now, when I get to the test, I'm actually going to have to go to the computer and try to take all of this thinking and put it into words. So let's think about how we can state some facts to start with. Well, let's think. It depends on what we want to explain. If you want to explain this one, you're going to talk about multiplication. If you're going to talk about this one, you'll need to talk about division in some way. I'm going to try to explain it in this way. I'm going to try to translate this into words. If you have this, I want you to try to see what your explanation would look like. And if you think you've got it, you can show me the explanation you've got outside of the video. And I'll tell you if you're on the right track and maybe give you a couple bonus G's for your extra work that you went to. So it says, enter your expression and your work or explanation in the space provided. Well, this must be the wrong thing because we don't have an expression really to enter. But it does say we need to explain and show how we determine this by entering our responses. So I might actually need to use some of these symbols. So I might show this in my work. If I were typing this in, I might show this. I might show 12 times 4 plus 1. If I was typing this in, I'm pretending, right? Would be the same thing as 12. And then I actually have a dot here that I can use for multiplication times 4 plus 12 times 1. And I can say that equals 48 plus 12. So far I've used this tool, as well as this equation editor tool. And so I might say this is, in my work I might label this as Jim. And so I can do this as well. I could show Jeannie's work, right? I can show 12. No, she doesn't start with 12. So here I would need to use my undo and my delete button. 6 times 8 plus 2 equals 6 times 8 plus 6 times 2. That gives me 48 plus 12. So, and then I would label that work as I type this in. Remember, I'm typing it in, not writing it. Or at least we're pretending that. This is Jeannie. This is Jeannie's stuff. So we've used all kinds of stuff. We use our parentheses, equal sign, addition, multiplication. All that stuff is working out for us. So now I've got to actually explain this. So I would need to state that I can maybe start with an assertion, right? I could start with an assertion. My assertion could be both Jim and Jeannie are correct. And so what would I follow up with? I would need to maybe state a fact, right? Maybe a fact or two. I might say I might say the distributive property states you can multiply the outside term, by all inside terms, and it'll still be equivalent. Okay, so there's one fact. My work shows when you do this with both expressions, you still get 48 plus 12. So I've got work shown. I've got two facts and an assertion. This is the kind of answer we would want to go in the box on Park.